Hey Valley Kids, tonight we're going to work on finding the area of composite shapes. Let's start off with something fun though. Our trivia question tonight, kind of quirky. How are fingers and tongues alike? We'll get back to that at the end of the video. Tonight we're going to get right into it and work on finding the area of a composite figure. Let's do this thing. Here we go. Find the area of this shape. Looks like something off of a basketball court. How do you do it? Ah! Well, I don't know either. Wait, I do know. I could find the area of this rectangle right here, and then I could find the area of the circle. I could cut the circle in half and add the area of the rectangle plus half of a circle. That's what I'm going to do. But see how I made a plan first? That's step one tonight. So I find the area of the rectangle. I just multiply these two areas together, 30 times 20, and I get 600 millimeters squared. Then I find the area of the circle. I take pi, 3.14, times 10 squared. This distance of the diameter of the circle is going to be 20 millimeters because it's the same as this one right here. So half of that is going to be 10. That's how I got the radius of 10. 10 squared is 100, so I take pi, 3.14, times 100 equals 314 millimeters squared. I have to take half of that because I'm only using half of the circle. Half of 314 is 157. I add that to 600 and I get 757 millimeters squared. I found the area of the rectangle, I found the area of the circle, I cut the area of the circle in half, I added the two together. Sounds like a lot, but if you take it step by step, it's not that bad. Let's review some vocab for tonight. Composite figure, that's a figure made of triangles, quadrilaterals, semicircles, and other two-dimensional figures. Here's a semicircle, that's a half of a circle. So to find the area of this composite figure, you'd find the area of the trapezoid and the area of the semicircle. To find the area of this composite figure, you'd find the area of the triangle and the area of the rectangle. Then you add them together. So here's our plan for tonight. We first make a plan. Then we find the areas. Then we add the areas together, and then we label and we check our work. Let's first review some of the area formulas. Here's the area formula for a trapezoid. It's 1/2 the height, this here, 1/2 the height, times base 1 plus base 2. So substituting that in here, the area will equal 1/2 of 8, that's the height, times base 1 plus base 2. And the bases are 10 plus 12. All right, I'll let you look at the rest of that. You could pause the screen if you need to study it. The way you find a triangle, area of a triangle is 1/2 the base times the height. The base here is 4, the height is 8. So we have 1/2 times 4 times 8. Base times height. And I'll pause and let you look at that. Okay. Next, area of a parallelogram. That is just base times height, like a rectangle. The height is 5 centimeters. The base is 8 centimeters. So it's 8 times 5, or 40 centimeters squared. Keep in mind that all area labels are squared. Centimeters squared, feet squared, miles squared, whatever it happens to be. And finally, the area of a rectangle. Some people say that the formula is length times width, or base times height. Either one works. This one here is 3 times 6, or 18 feet squared. All right, let's take a look at our first example for tonight. What is the area of this shape? All right, first of all, let's make a plan. I see a triangle and a square, or a rectangle. Do you see it? I thought so. So let's first find the easy one, the rectangle. I multiply these two together. The area of the rectangle will be 7 times 10, or 70. And a lot of times I label things as I go. So there's my 70. Then I find the area of the triangle. That's going to be 1/2 the base times the height. Well, if this entire thing here is 15 and this is 10, the height has to be 5 and the base is 7. So I put 5 times 7 in there. And of course that's 35, and 1/2 of 35 is 17.5. That's how I got 17.5. You could do that on a calculator. This is certainly a calculator target. Add those two together and we have 87.5 centimeters squared. All right, I made a plan, I added my areas together, and I checked my work. Looks good. All right, let's see how you do at making plans. I'm not going to ask you to solve all these tonight, but what I am going to ask you to do is make a plan to solve each of these shapes. Go ahead and take a look at shape A. How would you go about solving that? Let's see how you did. I'd break it right here. Whoops. I guess I'm going to have to get one out and draw it for you tonight. Let's get a line out. We'll make it, let's make it blue so it stands out a little bit. Yes, I would go draw it right across here and break it into those two shapes. On shape B, I would draw right across here. What would you do on shape C? Well, I'd break it into 3 rectangles. I got one here, I got the big one, and I would break this here. So I've got 1, 2, 3 rectangles I'm looking for the shape on. How would you find the shape or the area of shape D? I would break it into a triangle and a square. Find the area of each, add them together. What would you do on E? Well, I see a half circle, so if I found the whole circle and cut it in half, I could find the area of this, and then I could find the area of this one right here. This is kind of tricky, but the radius of this circle is going to be 7 because the diameter is 14. This one's a little tricky too. What would you do? I think I'd split it right down the middle here. I'd find the area of this trapezoid and the area of this trapezoid. And I know those formulas are a little bit tricky, but most of the time on testing situations, they will give you the formula, a list of formulas, and you just have to recognize that it's 1/2 the height times base 1 plus base 2. All right, very good. Make a plan, find the areas, add them together, label your work. Let's try some other shapes here. Yeah, but what about these? There are a couple of different yeah buts tonight. Sometimes you'll be given a shape that looks like this and you need to find the area. In this instance, count the full squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then count the half squares. Here I've got 1, 2, 3, 4. So I've got 10 full squares plus 4 half squares. 4 halves are like 2, so I end up with 12 square units. Okay, if there's no label, call them square units. So counting, numbering, or coloring them in as you go. I usually write little numbers in them. So that's one of the yeah buts. Here's another example of that. Here you'll find that you have 11 red squares. Those count the full ones. And then this is a different color. I think it's green or yellow. They did the halves in that color, so then you could more easily add them up. So you had 11 full squares. You had 8 of these halves, and of course 8 halves is like 4 wholes. If you add those together, you would have 15 square units. So that's one of the yeah buts. It's on grid paper. You can go ahead, do some counting, adding of halves and wholes. Here's another yeah but. What about these? Sometimes you just have to estimate. You do the same thing. Count the full and the almost full squares. So if you do that in this one here, you would find that there are 11. Then if you count the half squares like this one here, 1, 2, looks like we've got a third one here, and then maybe these ones down here count as a fourth, and you add those together, you got 11 plus full ones plus the 4 halves would give you 13. So again, you're just approximating it. It's the best you can do. And if you would come out with 12 or 14, the answers on a multiple choice test aren't going to be that different. You would be able to distinguish between them. They wouldn't have 11, 12. They wouldn't have 12, 13, and 14. They'd probably have one of those answers, and that's what you would choose. Okay? Again, it's an estimate in that case. Here's another example of something very similar. What about these? Here's an example. I can go ahead and I need to find the area of this shape here that's going around. Here, this one here. So what I did here was I just showed that I could go through and I could number the holes, and then I could go back and I could start counting in and go, well, These two would make one. I could count these two as one. You're combining halves. You're almost wholes. I would probably even count these ones here as wholes. Okay? Count the wholes, try to add up the pieces, add them together. All right? That is what I'm going to ask you to do for your ticket tonight. Take a look at this one here, and I've blocked out some of the halves and some of the wholes for you. You can see it was an irregular shape, and I just kind of drew in halves and wholes. That's another strategy. I want you to try and figure this out, and then I'll give you the answer to the trivia question. All right, tonight's trivia question. How are fingers and tongues alike? Everyone's fingerprints are different, and everyone's tongue prints are different. This kid, he's clean. He hasn't been tongue printed. This kid must be a crook. Look at that. They've already tried to tongue print him at the police station. Ha ha! It's a bad joke, but it's late at night, folks. I'm doing my best. Hope you enjoyed and learned something about composite figures. I'm just going to stress one more thing. When doing this, you need to, sorry, where's my slide? You need to make a plan, find the areas of the separate shapes, add them together, and then label your answer. Check over your work. Thanks and have a good evening.